Our robot this year is built solely on out-of-the-box ideas, starting with our passive starboard end effector, our 12 wheels, 1-to-1 gear ratio drivetrain, and our linear slide, which is actually used not only as our hanging mechanism, but also our block movement device. Most robots use a claw or a scoop to secure their autonomous block, but we just placed a block on the roll cage and let the robot do the rest. We also used a 40-point defensive autonomous program to give us an edge during the tele-op segment. We understand that the most important aspects of the game this year are hanging and autonomous, so we fine-tuned our robot to meet the needs of the hanging mechanism. But we kept our ideas simple, yet versatile, so we could achieve our goals. Our robot is adaptable to the needs of our other Alliance members, allowing us to play both defense and offense. Prior to the match, we team up with our other Alliance members and help them fine-tune their robot in order to maximize points. We use precision machinery to mill out our end effector. We've also incorporated a linear slide for lifting the robot in the blocks. The sprockets and chains efficiently move assemblies on our robot. We also use programs such as AutoCAD, SolidWorks, and Mastercam to help piece together our robot. Our team has designed our robot to be easily changed and modified. The drivetrain we've designed for our robot is connected on each side to make sure that no motors burn out. A threaded rod lift has been added to supply enough torque where needed. The wheels are equipped with a non-slip feature to keep our robot from being pushed around. The robot is also protected by a cage to keep every part safe and secure during each match. Our team uses SolidWorks to make sure all of the robot parts are working before they are implemented. Both the hardware and software teams work in conjunction with a schedule to allow for enough time to do both parts efficiently and quickly. The builders on our team test, try, and fix all of the parts on the robot until they all work 100% of the time. We use a lot of prototyping and modeling, especially taking advantage of our 3D printer to make parts and models, then putting them on our full-size prototyping robot for a real-life test before they go onto the competition robot. In our robotics team, everyone has their own job to do. They all work together on the robot. Our mentor throughout the program is Marcus Hazelgrove. The work is always divided equally, so everyone has their own tasks to do. One team uses Google Drive and Trello to keep up with the competitions and events. During FTC competitions, we usually try to get the crowd excited with cheers that we've made up. Our team is extremely passionate about robotics, and each year we try something new to let everyone know. In the off-season, members from our team educated elementary school kids on the basics of robotics and FLL. During the football season, our team brings our robots and other engineering projects out to share with other students and the community. Our robotics team is always well informed about what goes on in the FTC community. We watch videos, volunteer at FRC events, and have read the rules. We attend expos and present to outside sources in hopes of getting more sponsors. During FTC tournaments, our team usually helps and communicates with other teams to learn strategies. Every now and then, we invite other schools such as Western and FAU to our after-school club to help, build, and perfect each other's robots. We communicate with other schools and teams to gain knowledge and skills. Some of our team members have volunteered in FRC earlier this year. During competitions, we help our team members with the robot and programming. Every Wednesday, after school, we sell burgers to the students of South Plantation. All of the money is distributed as needed for food, parts, and events. We also have sponsors who fund our teams. Without them, we would have trouble with meeting our goals. One of our parent mentors keeps track of all the spending for documentation.